when the doctor gets seized or whatever, right? Okay, so if we do this network move to, again, you should look at my lecture on this, but network move to here, it moves the entity, okay? Well, it moves whatever entity is there. In this case, it's the person who's presenting for care. It moves it to rectangle 2, okay, to the specified node. And this node here is, in fact, rectangle 2. I mean, you can't see it because it's all together, but if it's in there. And in fact, if you were to look at presentation here, and you were to look at group, and you were to look at rectangle 2, it's this one right there. Okay, so that's why it's going to that rectangle. Okay, it's just taking some time. How quick does that entity move? Why is it going at a certain speed rather than other speeds? Well, if we go back to source, what we'll find is that if we scroll down, first of all, it tells what shape to use for them and so on, right? See this? It tells what shape to use, right? And then if we look at, I believe it's in here, I think, network move to. No, I am, I think, wrong about that. I should know exactly where that is. Here it is, speed 20, when they enter the network. Their speed is specified there. You see that? So if we were to specify this to be double that speed, let's suppose speed 40, okay, just for illustration here. And now suppose we were to run it again, okay? So we're running this this speed with speed 40, twice the speed here. Now you'll notice that, okay, here you notice they're going quite a bit faster. See that? Mm-hmm. And similarly, the doctor's speed was specified. The doctor isn't going any faster here. The doctor's speed, I believe, is specified right here because they're a resource. They're not an entity. They're a resource. They're needed to treat that entity. They're one of these resources from this pool. Their speed is specified here, and there's 3 of them. And entities are normally kind of interchangeable, and resources are too, but you can associate them with extra information, like an entity can be associated with an agent, or a resource can be associated, a resource pool could be associated with an agent. But these resources, there's 3 of them, and each of them moves with speed 30.
But they are not associated with the agents.
They are not.
They cannot.
The resources. No, right now they can't. Okay. But you could associate different. It would actually have to be different resource pools, and I have a model which has something like that. But right now they're not subject. They're not associated with an agent. They're not subject to getting sick. So this thing here, this moves. Remember, this moved them to that rectangle.
Yeah.
This network moved it to this rectangle too. Now, once they reach that point, then they can seize that individual, that agent, excuse me, that entity that happens to be associated with the agent, seizes a doctor from network resource pool. It should really be called like doctor resource pool or something like that. And you notice it says there's a maximum capacity of 100 people waiting, okay? It turns out there's also, you can have people leave on timeout, like if they don't get treated within a certain amount of time, they could leave and that sort of thing, okay? Now here's a delay, so there's a delay here. So once they've seized the doctor, they may spend a while, I should have emphasized, they may spend a while looking for a doctor because the doctor may be treating other people, right? And so they may spend a while, so a lot of people might back up, in fact. Might back up.
This queue capacity is like the capacity of this rectangle, not the...
Correct. It's of this particular area. And in fact, you could tell it, just use the maximum queue capacity. If you don't want to say there's some maximum, if there's no realistic, maximum within realistic bounds, you could just say use maximum.
What should the program do if the queue is full?
If the queue is full, if it fills up, well, okay, you could enable this thing to exit if they're waiting too long. Otherwise, it will just say queue is full, not handled. It'll tell you, and it will stop.
So not calling people into the hospital.
Sorry?
If the queue is full, then they will not call the people in.
Oh, no, it's still allowing them in, and it will just say, okay, it's overflowed, stop. So if you want to have extra logic to stop that, you could actually do that, but it would take some extra coding to sort of tell it to stop allowing people in based on that. Because you're right, there's another queue outside, of things. But let's just follow the logic here. So this one seizes, it gets associated with a doctor, okay? And the doctor's resource is sent here to the entity, okay? So that's why the doctor starts moving. It sends the seized resources to the entity, okay? Which is that person, right? And it attaches it in case the entity moves. Okay, now here is a delay associated with treatment. So the doctor has to treat the person, right? And this is a triangular distribution. Okay, so it's a distribution over some range, and then after they're treated, well, we saw this earlier. They're either with 0.05 chance they're treatment failure, otherwise 95% chance treatment success. Now you could have this. You could make it, if you want to add extra logic, that the chance of treatment failure goes up based on how many people are waiting or whatever, how many people are there, but it goes one of these ways, and then all that happens is it releases the doctor. The doctor's not needed after this point, so the doctor could serve other people. And here, you notice it says return to home location. Okay? So if we wanted, we could in fact have the doctor stay where they are. And so here, the doctor wouldn't have to come. Like right now, when the doctor is done, they go back to their home location, then they come back again. But that's kind of wasteful, right?
Yeah.
So here, they go up, and now they could treat people more efficiently because they don't have to keep on going up and down and up and down. You see what I mean?
Yeah.
Whereas earlier, we had them going up and down. So this is, you could start to see where these different pieces all come from of the observed behavior. What we had is this, right? And we could look at that. But here because the doctors had to go back to their home location, it took longer time. See, now they're going back. Even though there's people waiting, they're kind of going back for their cup of coffee or something. You see that? Which costs time, right?
Yeah.
Now, how much time it costs is a function of their speed and how long this path is and all those sort of things. Because you can draw out these paths, as much as you want, as complicated as you want, what have you. Quite complex anyway. So it's network move to, okay, this is just telling move the person to here, right?
Yeah.
To move them out. And then they get no longer associated with the system. They kind of leave the system and then leave that particular network. There could be multiple networks associated with one, like for different wards of a hospital, different areas. But here they sync that, then the person disappears. The entity disappears. It goes away. It leaves, right? And it's gone. But the agent is still around. It just had a reference to the agent.
Yeah, it's just a reference. So
It's just a reference.
if he get killed in this part, but he's still outside, so he can get affected by other people at the same time. So
say this again. If what?
Yeah, he get killed at this time, right?
If he got killed.
Gets cured.
Oh, cured.
Yeah,
If he gets cured,
yeah.
then he could. That's true. Then he could get infected almost immediately.
Yeah, it's synchronized with the.
Oh, that's a good point. That's a good point. So you could actually, you would have to add logic. Like if you wanted to, it's asynchronous, right? So like it goes on. This goes on at the same time that he's flowing through the system. So you're sending messages back and forth, but other persons could be interacting over the network with this one or what have you. And so he could get reinfected while he's still in the hospital.
Yeah.
Yeah. If you wanted to prevent that, you could have some sort of flag that would, prevent it from getting reinfected as long as he's in the hospital or whatever. But I think you see how these things work together now. And, you know, in your particular case, what I was suggesting is that you could actually have something beyond this, which is a clinic agent. And the
Yeah.
clinic agent, instead of this being in main, you could have a clinic agent which would have this inside of it.
Yeah.
And where the number of doctors here, instead of just being a fixed quantity specified, you know, in as a textual thing here, instead of being specified just here, you could actually have that specified by parameter for the clinic agent, right?
Yeah.
You see what I mean?
Yeah.
And then some clinics would be bigger than other clinics, and each would have its own, you know, queue here, and each would have its flow through, and the different agents, the different persons in the population could decide which clinic they want to go to, that sort of thing. Does that make sense?
Yeah.
Okay. Any other questions about this before I stop the recording?
I think I've already got it.
Okay. Okay. I appreciate you.
Alright.